All right, so the model imagines that there's just two people in the world, Smith and Jones. They have just two goods that they can possess, apples and oranges, and consume. They receive utility from consumption, okay, so they get happiness from eating apples and oranges. We imagine they know their preferences for oranges and apples. They know how to rank order bundles that they might be presented with. So many oranges, so many apples. How does it compare, one bundle compared to another? Do you like it more, less, and so forth and so on? That's what we mean when we talk about individuals' preferences. They can rank their desirability of different bundles of goods. We're going to imagine that the preferences have two characteristics. More goods are better than fewer goods, so more is better, and diminishing marginal utility and consumption, which we talked about and explained last time in class. We're going to imagine that Smith is endowed with 10 oranges, Jones is endowed with 10 apples, although we'll change that a little bit in our stories from time to time. We'll begin with different starting points or different starting endowments, and you're going to have to kind of think about how the analysis would change a little bit in response to a different starting point. But the endowments are what economists often call exogenous variables. I didn't define that explicitly in the notes anywhere, but exogenous just means given to us from the outside. We need that information to begin the analysis of the model, essentially, and this is information that's going to have to be given to you in a problem, for example. Now, we're going to imagine that Smith and Jones seek higher utility. That's the behavioral assumption we make in this particular model in the first brush of it. But a little bit later today, I'm going to make that assumption stronger. And we're going to imagine that Smith and Jones are rational and that they maximize utility, which is stronger than just saying they just trying to get higher utility than they had before. All right, and I'm going to show you the difference between those two a little bit later. Now, we're going to imagine Smith and Jones are willing to talk to each other and engage in trade potentially, and that they know perfectly the quality of the other's goods. We're going to explain that or use the term perfect information a little bit later. And when I talk about perfect information, it's going to mean that Smith and Jones know their preferences, first of all, their indifference curves as we're displaying them, and that they're going to know the quality and the features of the other goods that they're potentially trading for. And they need to have all that information for us to guarantee the kind of good outcome that we're going to end up with in this particular model. Now, here are some implicit assumptions, and these are still valid. And there are some other implicit assumptions regarding ethical behavior, for example, that we're going to get to next time in the next lecture. Now, indifference curves are our way of visualizing preferences of Smith and Jones. I'm going to jump right to the indifference curve diagram itself here. And note that this is our way of seeing the preferences of Smith and Jones, or Smith in this particular case. So notice we've got Smith down on the lower left-hand origin of this particular diagram. We've got oranges measured along the horizontal axis, apples along the vertical axis. And I do want to emphasize that one thing that you always should focus attention on when you see a diagram is look at what's being measured on the axes and look at what units they're being measured in. So oranges is measured in numbers here. See, so number of oranges. We could have picked a different unit of measure. We could have measured oranges in kilograms, for example. And in some problems, it'll be measured that way. Or in pounds. We could measure it in crates of oranges. You know, there's different units we could measure a collection of oranges in. And it's important in working through a problem later on to take note of what goods are in question and how those goods are being measured in the problem itself. But it's also important anytime you see a diagram to take note of what's being measured on the axes, because that's giving you information about what's actually being displayed. Okay, so we've got a grid here with all of the different combinations of apples and oranges that Smith might eventually consume. And we've got a collection of lines drawn here. Now the lines are called indifference curves. And each indifference curve gives Smith, I should say, a level of utility that's equal. So for example, a point like this on U equals 3, which is 1 orange and 3 apples for Smith approximately, is going to give Smith approximately exactly the same amount of utility as 4 oranges and say 8/10 of an apple, if we were to measure it accurately. Okay, so every point on an indifference curve gives Smith exactly the same level of utility. Now there's two features of indifference curves that correspond to the assumptions of more is better and diminishing marginal utility. The more is better assumption means that as Smith moves to the upper right part of this diagram, he gets onto a higher and higher indifference curve. If you're at a point like this, for example, and he moves from this point up to this point, then he's getting more apples and more oranges than he had before, and therefore, since more is better, it must put him on a higher indifference curve. Now you'll notice I I didn't draw it on indifference curves. It was 2 points right here that happened to be not on indifference curves. But you have to remember that there are an infinite number of indifference curves. So u equals 5 is up here, but through the upper point that I could draw another line that is parallel kind of to the curved line above it, and that might be u equals 4.8, for example. There will be an indifference curve like that, and there'll be one for u equals 4.5, and for u equals 4, and so forth and so on. So there's an infinite number of indifference curves corresponding to every level of utility or happiness that Smith might enjoy from apples and oranges. But we only represent a few of them. We only draw 2 or 3, or sometimes only 1, to give us a sense of Smith's indifference curves, his preferences for a particular good. Now, there's one other feature that's incorporated in these indifference curves. The curvature of the indifference curves, the fact that they're curved towards the origin like this, means that there's diminishing marginal utility in consumption. And that's explained a little bit in the note, but I want to highlight the fact that if we change that assumption, it changes the nature of the indifference curves. So for example, if we had constant marginal utility, where each additional unit of a good gave Smith a fixed amount, say 2 extra utils of utility for every additional apple, and the third apple gave him an additional 2 utils, and the fourth apple gave him an additional 2 utils, and so forth and so on, if there was constant marginal utility, then the indifference curves would look like this. They would be straight lines instead of curved lines like this. And if, in the odd case, in a situation I can't quite comprehend for a particular product, if Smith exhibited increasing marginal utility, then the indifference curves would look like this instead. Okay, so the shape of these indifference curves are incorporating that feature of utility or of his preferences. And that's going to mean also, one of the things you might be worried about looking at this for the first time is, where do these indifference curves come from? And am I going to have to draw them in some way? The answer to that is most likely no. I won't have you draw indifference curves. You'll likely only be presented with indifference curves and then asked to interpret them. But if I did ask you to draw them, all you have to do is to draw a series of lines that looks much like this with the curvature towards the origin. And that's going to represent some sort of set of preferences that match the assumptions that we're making about Smith's preferences. Okay? So, I mean, his indifference curves could look much steeper than this. They could look like this, for example. Still curved a little bit towards the origin, but not so much. They might get wider as they come down. They could look all sorts, but they have to have this feature where utility is increasing in this direction and they're curved somewhat in the direction of the origin, and that gives the diminishing marginal utility assumption. So we can just kind of randomly draw up these curves with these features, compare them, Smith versus Jones, in a little bit, and that's going to give us the insights that we need. Let us move on to the next diagram. This is what I just said. It's there for your reference. Now, here's another set of indifference curves. They're drawn very similar to the ones before, but not exactly in the same shape and the same direction. They also intersect the axes right here and so forth. And I didn't label them with utility numbers now. I just labeled them I1, I2, and I3. But we should know that I3 gives Smith a higher level of utility than I2, which gives a higher level of utility than I1, and so forth and so on. Now, we're going to introduce Jones into the mix here. And the one thing we're going to do in order to create an Edgeworth box is to make Jones upside down. We're going to put Jones's origin up here. Notice we put his name next to his origin. And Jones is going to have an increase in oranges moving in this direction to the left above, and an increase in apples moving in this direction. So more is better for Jones is going to imply that Jones's utility is increasing in this direction. All right, that's giving Jones more of both apples and oranges as measured from his particular origin. All right, and he's got indifference curves that are shaped and bowed in the direction of his origin here, right? They're curved in that direction. And that gives Jones diminishing marginal utility in the consumption of both apples and oranges as well. All right, so both of those assumptions are now incorporated in a systematic way in Jones's depiction of his indifference curves here. Okay, now, you should see in front of you two diagrams. The left side depicts Smith's preferences for apples and oranges, his indifference curves. And on the right-hand side, we've got Jones upside down with his indifference curves. And we're now going to imagine that Smith and Jones are endowed with a certain number, a certain amount of apples and oranges. So just as before, we're going to say, let's suppose that Smith has 10 oranges and 0 apples. If that's true, then Smith's position on his diagram initially is going to be here at ES, E for endowment and S for Smith. All right, and Jones, we're going to imagine, has 10 apples and 0 oranges. So for Jones, his endowment is going to be here, adding up 10 apples downward in this direction to 10, and 0 oranges puts him at EJ. Endowment for Jones is at this particular point. Now, to create an Edgeworth box, which is going to give us all of our action we need and the implications of this model, we're going to have to take Jones's upside down diagram and we're going to move it over and superimpose the endowments on top of each other. And it's going to look something like this, about like that. And we put them on top of each other. And as a result, the Edgeworth box that we've now constructed is actually a box that has dimensions 10 oranges wide by 10 apples high. And it's going to give us a record or a way of recognizing all of the different combinations of apples and oranges that Smith and Jones could ultimately end up with. Now, what they start with is down here at the corner, right? ES and EJ are on top of each other. So the endowment for the two individuals always has to be exactly in the same spot in the Edgeworth box. All right, and so that's a feature that will always play out regardless of how this box ultimately looks in a problem, for example. But I want to give you also a little bit of a heads up and note how it might be different if we started with a different set of assumptions. Let me go back to the start. Let's imagine we have Smith come to the market not with 10 oranges and 0 apples, but suppose he comes to the market with 1 orange and 6 apples, this point right up here on his graph, right? Okay, and let's suppose Jones comes to the market not with 10 apples and 0 oranges, but with 1, 2, 3, 4, 7 oranges and 2 apples right here. Okay, well, if those are their endowments, then to create the Edgeworth box, we're going to take, again, Jones's diagram. We're going to superimpose the endowments. All right, so now with Smith having 1 orange to the market, Jones having 7 oranges, the total number of oranges is the length of the Edgeworth box, which is 8 oranges. The height of the box is given by Smith's 6 apples that he brings to the market, and Jones's 2 apples. The sum of that is 8, so the height of the box is 8. So now the Edgeworth box is this smaller box noted here, because where the endowment is now not on the edges, but it's in the middle of the box, not really middle, but it's on the edge right here. It's in the interior of the box, better way to say it. Okay, and then that gives us a slightly different look for, we'll see, for potentials for trade and whatnot. So that's the interpretation of the box. The box is giving us the starting point of the endowment. It's where we're superimposing their endowment points on top of each other. The dimensions of the box give us the total amount of apples and oranges that are available in consumption for both Smith and Jones, all of the allocations that might be possible. And the first exercise that you might be faced with in looking at a particular Edgeworth box is going to be to identify who has how many goods at a particular position on the box. Now, we've already talked about the endowment here, the endowment point E in the lower right corner. We know how many apples and oranges Smith and Jones have. But suppose we were, for whatever reason, at a different point, like G. Okay, and we could ask, I might ask you, if you're faced with this diagram, how many apples and oranges would Smith have if he were positioned at point G in the diagram? Well, to answer that, you start from Smith's origin down here and you count over and up. So 1, 2, 3, number of oranges, 1, 2, 3, 4, 5, 6, 7 apples. And so Smith is going to have 3 oranges and 7 apples at point G. I could ask you how many apples and oranges would Jones have at point G? To answer that, you're going to start at Jones's origin up here and you're going to count over and down. So 1, 2, 3, 4, 5, 6, 7 oranges and 1, 2, 3 apples. Jones would have 7 oranges and 3 apples if Jones were positioned at point G on the diagram. And you can do that for every point on the diagram. What about point J? What about point A? What about point C? On and on. Every point represents a mixing up of the 10 apples and 10 oranges between Smith and Jones, giving them different amounts of each of the goods in each of the different positions. All right, so the Edgeworth box is really cool because it's now giving us a visualization of all of the possible places that Smith and Jones could end up with or move to after trade. Okay, so let's get to the next point. Any diagonal movement from the endowment point, E, represents trade. Any diagonal movement. So diagonal movement means not, well, it's going to mean in this direction from E, because that's the only diagonal direction you can go in. So if Smith and Jones were to move, for example, from E to D, in order to achieve that reallocation, here's what's going to have to happen. Smith, starting with 10 oranges and 0 apples, is going to have to give up 1 orange and receive 1 apple in order to get to point D. right? So that corresponds to trade for Smith. I give up an orange, I get an apple, I end up at point D from Smith's perspective. From Jones's perspective, he's going to say, oh, to get to D, I have to give up one apple and I'll receive one orange from Smith. So Jones is giving up an apple, receiving an orange, same trade because they're working with each other. And therefore, a movement from E to D represents exchange. I'll give you this, you give me that, of certain amounts, and we end up at a different position in the Edgeworth box. Okay, and that's going to be true for any point here, B, F, G, C, H, J, and so forth. There's 2 points on the diagram that are listed there where it's not going to be representing trade. So for example, if they move from point E to point K, well then trade is not taking place. Instead, what's happening in going from E to K, it's not a diagonal movement, notice, is moving from E to K, what's happening? Jones is giving all of his apples to Smith and receiving nothing in exchange. Okay, so there's no trade in going from E to K, which is why there has to be a diagonal movement in order for trade to take place. Okay, now, here's the cool part about the diagram. The diagram is important because in this diagram, we have represented all of the assumptions that we've made up above. Everything is in there, and we can now visualize all of the different possibilities that are open to Smith and Jones. And we can also visualize kind of what trades are going to make them better or worse off. So for example, if they were to trade from point E to point B over here, noting that we have the red indifference curve passing through point E for Smith, if they were to move from E to B, well, since B is below Smith's indifference curve that passes through the endowment, we know that a trade to B would make Smith worse off. 1 orange and 3 apples is just not as good to Smith as 10 oranges and 0 apples. So we would imagine Smith, being an individual who wants to increase his utility, wouldn't accept a trade to B. He'd just say no to that and would walk away if Jones was insistent in saying, I'll only trade to point B. Okay? Similarly, if they were to trade to a point up here on the upper right of the diagram, this would be below Jones's indifference curve, which is the blue line passing through E. And if they traded from E up to this point, call it L, then at that point, Jones would be worse off as a result of the movement, and Jones would refuse to trade to that particular point. Jones might also refuse to trade to a point like J, because at point J, Jones doesn't get any better than he would be at point E. He's indifferent between E and J because it's on the same indifference curve. Okay, so we know that Jones would probably not accept a trade to point J either. Okay, but where would they accept trades? They would accept trades, both of them, if they were to move into this space up here, which is what I'm calling the lens. If they move into this space, then like at point H, right in the middle, Jones is on a higher indifference curve than he would be on the indifference curve passing through E. And Smith would be on a higher indifference curve as well. So if they move to the middle of the diagram, into the lens, what I'm calling it, then both Smith and Jones are going to become better off as a result of trade. Now, I would encourage you to think about, for a moment, what if we didn't have the diagram in front of us? What if we didn't know exactly how to draw indifference curves, or we didn't know how diminishing marginal utility might be represented and so forth? We wouldn't have a way of knowing whether there were a whole bunch of trades possible where Smith and Jones would both be better off. It's the visualization that gives us the ability to kind of see what exactly are possible outcomes and why it really is quite likely for Smith and Jones to be able to both be better off as a result of the movement to trade. Now, I want to give you just a little bit of intuition about that result. Why is trade mutually beneficial? Why is it a win-win situation where both of the parties walk away happier after trade than they would be before trade? Well, the intuition really lies in thinking hard about that assumption of diminishing marginal utility. So let me give you an example. Let's go back to E and imagine that Smith and Jones are just going to make a simple, easy trade from E to D. 1 apple for 1 orange. Well, why would Smith be willing to give up 1 orange for 1 apple, and why would that make him happier? Well, again, think about what diminishing marginal utility means. And imagine that Smith, is consuming oranges every day, day after day after day. What Smith is giving up in trade, moving from E to D, is his 10th orange. Not just any orange. It's his 10th orange of the day. And the 10th orange, we know from diminishing marginal utility, gives him a whole lot less additional utility than would, say, the first orange that he consumed during the day. So just comparing the first orange with his 10th orange, the 10th orange is not as valuable to Smith. It's not worth as much. Why? Because he's tired of eating oranges all day long. All right, but he's got a possibility in moving to D to trade his not so desirable 10th orange for a very desirable first apple. And that first apple, being the first, being a new product, being a new taste for the day, is going to give him quite likely a much higher level of utility than his 10th orange. And thus, by changing his allocation, by moving from 10 oranges and 0 apples at E to 9 oranges and 1 apple at D, Smith actually has a higher level of happiness or utility as a result of that new bundle. And that's why he's happier. Same thing is true for Jones, right? Jones is giving up his less desirable 10th apple in exchange for his more desirable first orange. And as a result of that, Jones is happier as well. So here we get what is a really critical aspect of the economic reality that's out there. When trade occurs, and when it occurs voluntarily, as we're imagining here, both of them are moving to a point in the lens because both of them are happier, then trade is actually a good outcome for both Smith and Jones. We can say everybody in our world, because there's only 2 people, everybody is better off as a result of trade. And that's a really important and cool result.